So the size reduction is a very vital process concerning to the raw material processing. It creates an uniform size used for manufacturing of API or formulation. See, the comminution or size reduction is nothing but when you have an uniform size of particle, it is very helpful for standardization process. So let us discuss the factors affecting the size reduction. Number one, hardness. Okay, the hardness in a Mohs scale, the hardness, if it is 3, the Mohs scale is 3, that is soft material. 3 is a soft material, but if it is 7, it is a hard material. Okay, so hardness. Number 2, toughness. Hard brittle material can be easily reduced than soft and tough material. Okay, like rubber become brittle at minus 100 degrees centigrade. Then number 3, abrasiveness. So in abrasiveness, the quality, the wearing and tearing effect, that is wearing the machine and get contaminated, that is abrasiveness. Number 4, stickiness. Gummy material exhibit difficulties in size reduction. Softening temperature, like wax material soften during size reduction process. Then material structure, whether it is crystalline or cellular. Normally crystalline structure can be easily reduced to a desired size. Moisture content, less than 5%, used for dry grinding, and more than 50% used for wet grinding. Okay, then coming to the ratio of feed size to product size is the number 8 in the factors affecting. Then the very important part of size reduction is the principles of size reduction. The first principles is coming to the Rittinger's law. Okay, so what is this suggest? The energy for comminution, okay, energy for size reduction is directly proportional with the new surface produced or new surface area produced. That is, your energy is equal to one constant Kr Sn minus Si. Okay, then you have Kick's theory. The Kick's theory says that it's for the large particle. Energy of deformation of set of particle or equivalent, energy of deformation of set of particles of equivalent shape is proportional to the ratio of the change in size. That is, E is equal to your K log, that is a Kick's law constant, log diameter di dn. Okay, this is the equation, d for the diameter of the particle. Then you have a third principle, that is Walker's theory, Walker apostrophe, Walker's. It says that the energy differences are nothing but minus kW, okay, into delta D upon delta dn, okay. So normally it's a link between Rittinger's and Kick's law. Now if n is equal to 1, then the Walker is a Kick's law. Okay, if n is equal to 2, the Walker is Rittinger's law. If n is equal to 1.5, it is neither Kick's or nor Rittinger's law, it is Bond's law. Okay, or Bond's theory. What is that? Bond's theory, it is useful for rough milling process. That is, energy is equal to 2 kb upon into 1 upon root over dn minus 1 upon root over di. Okay, the initial and the final diameters. Now this is the principle involved in size reduction process. Now let us go with the equipments used for size reductions. Okay, so equipments used. Now if you see the equipments, the first one is hammer mill. Okay, now before go for equipments, let us discuss the mechanism of size reduction. Okay, Number one, cutting. Number two, compression. Compression, you have two part: trituration and the levication. Levication you did on a tile, okay, while preparing paste, okay. Then you have impact, then attrition.